This is the objective for this experiment to determine the drop time of various weight of the flywheel apparatus through experiment and compare to the value using theoretical equation. This is flywheel apparatus, weight hanger, weight 200 gram, and then marker pen. Measuring tape, and the last one is stopwatch. This is all the apparatus. For the step 1, measure the dimension of the disc and needle by using the proper instrument. Repeat the measurement and take the average measurement. For the step 2, wind the string around the axle, record the number of turns, make sure the string is hang freely. Place a weight hanger to the string holder. Suspend 0.4 if the load on the string, and take time after releasing the mass from the rest until it reaches the minimum point, and then repeat the step for the step 2 and the step 3 using the same procedure. For step 5, repeat the step 1, 2 and 3 with every 0.4 kg increment with 2 kg. Calculate the mass of this axle using the equation P equal to mv, given the density of the flywheel is 7,870 kg meter cube, and then determine the angular acceleration, linear acceleration, and the moment applied to the disc and axle for each value of m. And then plot a graph moment against the corresponding value of angular acceleration and determine the slope of the best straight line representing the plot point to find the experimental moment of inertia. And then calculate the total amount of inertia of the disc and axle given the density of the disc and axle is 7,870. Hi, my name is Alex Anthony. This is for the flywheel apparatus experiment. This is the result. As you see here, this is the formula that I use for finding the angular acceleration, linear acceleration, and the moment of the system. Okay. This is the flywheel result for the axle dimension. This is the dimension of flywheel disc diameter is 0.304 meter. Axle diameter is 0.029 meter. Flywheel dip is 0.38, and then axle length is 0.315 meter, and number of turn of string on axle is 7 revolution. This is the time taken, the drop time taken for each mass from rest to minimum point. If you see, we have 1, 2, 3, 4, 5 lot. Okay, that's starting from 0.4, 0.8, 1.2, and 1.6, and lastly is 2.0. If you see, we take 3 time for that we record. We make it repeat for 3 times, and then we plus the we sum all the time that we get, and then divide it by 3, and then we will get the average time. So this is the average time. As we see here, the when the load is increased, the average time is decreases. And then for the angular acceleration, this is the result, and also the linear acceleration at the moment. The answer is based on the in this previous slide. We use this formula, like 7 times 2 pi divided by the time that we get. The time is the average time, so we put in there, and then we will get the angular acceleration. And then for the linear acceleration, we find with this formula 0.0125 time with the angular acceleration that we get. And then for the moment, we use this formula. For the moment, we use the mr GA minus GA, that is m is the load, r is the radius of the axle, and a is the acceleration, and g is the gravitational acceleration. And then we go to discussion. This is the free body diagram for the flywheel and the weight, as you can see here. Compare and discuss the result of the drop time and the moment of inertia for the various weight of the flywheel apparatus using the theoretical equation, and compare to the measurement in the experiment. The average time is longer when the mass is the lightest, as demonstrated in the result. Meanwhile, the bigger the mass, the less time it takes to reach the ground on average. When the load with the greater mass travel to the ground, the inertia increases, the travel velocity increases, the angular velocity increases, and the average time to reach the ground is the shortest, according to the formula. Give your comment or a suggestion, at least 4 causes of error that may affect the result of the experiment. For the first one, the length of the string should be less than the height of the axle from the floor, and then error during taking the time taking is because take the time for the stopwatch might be delayed and causes error reading. The flywheel should have least amount of friction possible. String should be thin. And then for the conclusion is the verified Newton's second law for rotational motion M is understood. To determine the moment of inertia of a disc and axle from experiment has been successfully obtained. To determine the frictional moment required to overcome the friction is successfully obtained. To determine the moment of inertia of a disc and axle using the theoretical equation is successfully obtained. So I think that's all from me. Thank you.